You know that feeling, right? You type the most perfect, detailed prompt into an AI image generator, and it just ignores a key detail or gets all the colors wrong. It's a super common frustration. But what if there was a simple, kind of elegant way to fix it? Well, a new method claims to solve this exact problem, and honestly, the results are pretty stunning. Let's dive in.
Okay, just take a look at this. The prompt was a pink teddy bear with a white head and blue crown sitting in a green chair. On the left, a standard model gives us, well, a pink bear on a bluish chair, and it completely forgot the crown. But on the right, with this new technique applied, it's perfect. Every single detail is exactly where it's supposed to be. This is the exact problem we're going to unpack today.
Now, it's really easy to think of these AI errors as just random glitches, but they're not. They're actually specific, predictable failures. Researchers even have a name for these creative blind spots, and understanding them is the first big step to actually fixing them. So that first problem, the missing crown, is something you've probably run into yourself. You ask for a cat wearing a hat, and you just get a cat, or a car next to a tree, and you just get the car. This actually has a name. It's called catastrophic neglect. It's basically when the AI gets a little overwhelmed by how complex a prompt is and just drops one of the concepts. It doesn't really know how to prioritize, so some things just get left behind in the process. What's really fascinating here is that this slide shows us why it happens. These heat maps show the AI's attention over time. In that top row, you can see the attention for the word crown just fizzles out. It fades to nothing. The model literally forgets about it. But the bottom row shows how this new method keeps that attention focused, basically forcing the model to remember and generate the crown.
Okay, so the second big problem is what researchers call attribute binding failure. This is when the AI generates all the right objects, but it gets the details all mixed up. You ask for a red ball and a blue box, and you end up with a blue ball and a red box. Sound familiar?
And this visual just illustrates the issue perfectly. On the left, the standard model's attention maps show total confusion. The attention for green is bleeding all over the bear, and the attention for pink is on the chair. It knows the words, but it just can't connect them to the right things. But on the right, the corrected version shows these crisp, separate areas of attention. Green is only on the chair, white is only on the head. It just works.
And the third problem is really all about control. They call it poor layout guidance, which basically means you can't really tell the AI where to put things. You can say a cat on the left and a dog on the right, but the final placement is often just a suggestion that the AI might completely ignore. So, to recap, we've kind of zeroed in on these three huge problems. You've got neglect, where objects are just plain forgotten, binding, where all the details get jumbled up, and layout, where we have almost no control over where things go. And it turns out solving these is a major focus for AI researchers right now.
And hey, this isn't just a user complaint, it's a massive deal for the folks building this stuff. As the authors of the paper we're looking at today put it, this lack of control is a key challenge that's holding the whole technology back.
But what if there was a solution that didn't require rebuilding these massive, complex models from scratch? That's where this new method comes in. It's called Box It to Bind It, or B2B for short, and it is incredibly clever. See, the really big idea behind B2B is that retraining these giant AI models is incredibly slow, it's expensive, and it requires these enormous data sets. So instead of trying to change the model itself, what if we could just guide it better while it's making the image?
This slide really breaks down the difference. On the left, you have that standard approach, a slow, expensive, complete overhaul. But the B2B approach on the right is the total opposite. It's training-free, which means it works with existing models like Stable Diffusion. And instead of a huge dataset, it just uses an LLM like GPT-4 to plan things out. It's not a new model. It's more like an intelligent guide that plugs right in.
So how does this clever little guide actually work? Well, the magic is in its process, which breaks down the super complex task of creation into three simple, logical steps: plan, generate, and bind. It's a really beautiful, simple process. First, it sends the prompt to a large language model, which thinks about all the spatial relationships and draws these simple boxes for where each object should go. You can think of it like a blueprint or a coloring book outline. Second, it tells the image model, okay, generate the bear inside this box and the crown inside that box. And finally, it enforces the rules, making sure the color blue is only applied to the crown inside its own little box.
This diagram shows the whole system in action. The prompt goes in,
The LLM creates the layout, and then at every single step of the image generation process, this B2B module is nudging the AI's attention. It's constantly checking, is the right object forming in the right box? Is the right color being applied to the right object? It's kind of like a conductor making sure every part of the orchestra is playing the right note at exactly the right time.
Okay, so the theory sounds great, but does it actually work in practice? The researchers put B2B through a whole series of tough tests against other state-of-the-art models to find out. Check this out, a super simple prompt, a red dog and a black dog. The baseline model on the left gets totally confused. It gives us this weird black dog with another smaller black dog and a red collar. It's just a mess. But the B2B result on the right? It's perfect. Two distinct dogs, exactly the right colors, exactly where they're supposed to be.
All right, now for something much more complex. A black robot with white wings is watering a fluffy flower. The standard model on the left produces, well, a mess. It's sort of an abstract blob that vaguely has the right colors. But the B2B version is just stunningly accurate. The robot is black, its wings are white, and it's clearly interacting with a fluffy flower. It nailed the objects, the attributes, and the spatial relationship between them.
And the numbers tell the exact same story. This table shows the performance scores on a standardized test. For collar binding, B2B jumps from a 56 all the way up to over 85. And for getting the layout right, that's spatial reasoning, it leaps from 55 to a staggering 88. These aren't small improvements, folks. They are absolutely game-changing. So what does all of this mean for the future of creative AI? Well, it means we're moving from an era of happy accidents to a new era of intentional creation. So what does this all unlock for us? First, it just means more reliable tools. We can finally get the image we actually asked for. Second, it gives us way more creative control, letting us place objects exactly where we want them. It also makes creating complex scenes with multiple subjects so much more straightforward. And maybe the best part? It does all this by working smarter, not harder, upgrading the AI we already use without that massive cost of starting over from scratch. And this brings us to a really fascinating final thought. For years, we've been the ones learning how to speak AI, tweaking our prompts, trying different phrasing, and just hoping for the best. But with tools like this, the AI is finally learning to speak our language. It's understanding not just our words, but our intent and our sense of composition. This isn't just about making better pictures of teddy bears. It's about a future where complex visual ideas can be brought to life instantly. So the question isn't just, what will you create? But how will storytelling itself change when imagination is the only barrier left?